Okay, so we're going to be talking about long division, polynomial long division, but I want to start with regular long division that you learned back in elementary school. Okay, so long division is when you set your division up this way. Now, this is the same thing, and this is the same thing. All of these three things mean the same thing. I'm going to take 1,378 and divide it by 3. Okay, the difference is this allows us to do the algorithm of long division very simply. This would be creating a fraction. This is what we call an improper fraction. And this is just showing that I'm dividing this by this. Okay, this would be kind of something you would put in a calculator. So we're going to go back and think about this the way we were taught back in elementary school. So first thing you do is say, okay, how many times does 3 go into 1? 0 times. Okay, then we move on. How many times does 3 go into 13? We say, okay, well, it goes in 4 times. And then we say, okay, 4 times 3, that's 12. And then we subtract. So 13 minus 12 is 1. Then we bring down our next number. And then we do the same thing. We go, okay, how many times does 3 go into 17? And that's 5 times. Okay? And then 5 times 3 is 15. We subtract 2. Then we bring down our 8. Then we go, how many times does 3 go into 28? Well, that's 9 times. And 9 times 3, that's 27. We subtract, we get 1. So when we take 1,378 and divide it by 3, we get 459 with a remainder of 1. So that's 459 whole pieces with 1 remainder, which means basically you could either keep going by putting a decimal here and put a 0 and then bring the 0 down and keep going, and you'd find out that it'd be 459.33333 repeating, or we much would rather write like this. We have 459 wholes with 1 remainder over 3, which basically means that we still have to divide this 1 by 3, but it doesn't go in evenly, so we end up with 1/3 as our extra remainder. Okay? And if you did that with this one, you'd get the same thing. You would basically get this many whole 3/3s with 1/3 left over. Okay? So let's take this idea and now apply it to something like this. Okay? So now I've got not numbers, but I have polynomials. So I'm taking this polynomial and dividing it by this polynomial. Now, one thing that we forget is that when we do division like this, when we have this fraction bar, that there are implied parentheses. The top has parentheses around it and the bottom has parentheses around it. So basically this is saying this whole quantity divided by this whole quantity. You can't break it apart. You can't just go, oh, I'm going to take x squared and divide it by x and -6 and divide it by 2 and get x minus 3x plus 17. It doesn't work that way. It's this whole thing divided by this whole thing. Okay, just like it is up here. So we're going to change this to its long division form. And just like this one, the denominator goes on the outside, so we get x plus 2, and the numerator goes inside, x squared minus 6x plus 17. Okay? Now, we have it set up for a long division. We're going to think about it just like what we did here. The difference is, again, we have to remember that this out here is still has kind of like parentheses around it. And instead of saying, okay, how many times does 3 go into each number, we're going to say, okay, what am I going to multiply this x by to get this first term to be the exact same thing? So what times x gives me x squared? Well, that's easy. X. X times x gives me x squared. Now, just like I did up there, when I multiplied the 4 times the 3 and got 12, I'm going to multiply this times this, but the whole thing. So I have to multiply it by both of the terms in there. So x times x is x squared, and x times 2 is 2x. Okay? Now, again, just like at the top, I'm going to subtract, but I have to think of it as subtraction here with parentheses around it, so I have to actually distribute my negative sign into all of my terms here. So this one's going to be negative, and this one's going to make this one negative. okay? Then you add x squared minus x squared, that's 0, and negative 6 minus 2 is negative 8x, okay? Now just like over there, I'm going to bring down my next term, 17. And now we're going to do the same thing we did here. So what am I going to multiply x by, this one, to get negative 8x? Well, that's easy. Negative 8. Negative 8 times x is negative 8x. So we get negative 8x, but we have to also multiply it by the 2, so we get negative 16. And just like before, we're going to subtract, which changes the signs. So this negative becomes positive, and this negative becomes positive. And then we add down, so negative 8 plus 8 is 0, and 17 plus 16 is 33. Now there's nothing I can multiply x by to get just 33, so there's nothing else I can do. This is my remainder, okay? So my answer to this is x minus 8 plus my remainder, which is 33, that still has to be divided by my x plus 2. So basically this is this divided. And that's polynomial long division.